Hello, my name is Dr. Fitzgerald, and in this session, we want to discuss simplifying radicals. So we'll look at examples that aren't perfect squares or perfect cubes, and how do we simplify in that case. So let's look at a couple of examples. The first example we will look at is, how would I simplify if I was asked to simplify the square root of 18? Well, the first question I would ask, is the square root of 18 a perfect square? Is 18 a perfect square? And the answer to that question is no. 18 is not a perfect square. So in this situation, what do? We want to break down 18 into two factors, in which one of the factors is a perfect square. So can we do that? Can we break down 18 into two factors in which one's a perfect square? And the answer is yes. 18 really is 9 times 2. And this is great. Why is that perfect here? Because, well, recall, we could break down and use the rule, and I will only do it this one time, but in this particular case, we can break down using the rule and write this as the square root of 9 times the square root of 2. And that's just a rule of radicals that we had. And that's great in this big case because here is my perfect square. The square root of 9, that's a perfect square. And the 2, well, the 2, this is my leftover. This is what's left over. So we broke it down into something that's a perfect square and then what's left over. And when I go and simplify this, the square root of 9, my answer is just 3. And then what's left over? The leftover part is the square root of 2. So my final answer in this particular case is 3 times the square root of 2. Our next example that we'll look at is if I had the square root of 75. So once again, I'm asking myself, is 75 a perfect square? And the answer to that is no. And then I want to break up 75 into two factors in which one is a perfect square. So that one's kind of easy. That one we would break up as 25 times 3. 25 times 3. And note that 25 is my perfect square, and then the 3, the square root of 3, that's the leftover part. So how does this guy simplify? When I rewrite this guy, the square root of 25 is simply 5. You got it. And what's the leftover part? The leftover part is the square root of 3. So my final answer is 5 times the square root of 3. Let's look at one with a cube root. Let's see how good you guys are getting with this examples. Let's look at the cube root of 24. The cube root of 24. So is 24 a perfect cube? Now we're looking at perfect cubes, not perfect squares. So we need to be able to multiply something by itself 3 times in order to get 24. And is there such a number? And the answer to that question is no. So what do we want to do? We want to break up 24, once again, into two factors, and which one's a perfect cube, and which the leftover part. So how can we do that? Well, 24 is simply 8 times 3. That's my 24. And I'll break it up just like I did that other one, just so that you can see that my cube root of 8, that's my perfect cube, and then I'm left with the cube root of 3. So once again, this guy is my perfect cube, and then this guy is my leftover. That's what's left over. So what happens when we simplify this guy? Well, my perfect cube, which is the cube root of 8, that guy just simplifies to 2. And then the cube root of 3, well then that's left over. That's simplified. We can't do anything else with that. So we have the leftover part, which is the cubed root of 3. So 2 once again comes from the cube root of 8. And then the leftover part is the cube root of 3. And that's my final answer. One more cube root example, and I think you guys are well on your way. So let's look at the cube root of 54. The cube root of 54. So let's think of our perfect cubes. Well, first of all, there is no number that I multiply by itself 3 times to get 54. So 54 is not a perfect cube. But let's look at it. How can I break up 54? And I want to break it up as the cube root of 27 times 2. 27 times 2, that gives me 54. And 27 is my perfect cube part. And then this guy is my leftover. That's my leftover part. So let's look at that. What's the cube root of 27? Well, the cube root of 27 is simply 3. And the leftover part we're just going to write, which is leftover with the cube root of 2. So this guy breaks down to 3 times the cube root of 2. And that's the final example for that one. Now, I do have 2 problems that I would want you to try, and I want to write them right in the center here. So I want you guys now in the green to try at home. The first one is the square root of 32. The square root of 32. And the second problem that I want you to try at home is the cube root of 125. So your 2 problems to try at home is the square root of 32 and the cube root of 125. I know you guys can do it. So try those examples, have those ready for me, and we'll talk more about this simplifying radicals later. Thank you.